Artist's illustration of NASA's Juno spacecraft at Jupiter. The probe entered orbit around the Solar System's largest planet on July 4, 2016. Credit NASA's NASA's Juno spacecraft, which arrived at Jupiter on July 4, 2016, is studying the planet in detail to give scientists a better idea of the gas giant's weather, magnetic environment and formation history. Juno is only the second long-term mission at Jupiter after the Galileo spacecraft, which orbited the planet from 1995 to 2003. However, Juno's mission is planned to last for a much shorter period, as it is currently being targeted to impact Jupiter in February 2018. Juno is one of NASA's 3 New Frontiers probes. The others are New Horizons, which flew by Pluto in 2015, and OSIRIS-REx, which is expected to fly to asteroid 101955 Bennu in 2020 to collect a sample and return it to Earth. New Frontiers was a program NASA created in 2003 for medium-sized missions that are capped at $1 billion in development and launch costs each. The Curiosity rover, by contrast, cost about $2.5 billion. A fourth mission is expected to be selected in November 2017, with a launch for 2024. The National Research Council identified a Jupiter orbiter as a scientific priority in 2003 in its decadal survey, New Frontiers in the Solar System: An Integrated Exploration Strategy. Among the questions raised at the time were: does Jupiter have a central core, which will help narrow down how the planet was formed? How much water is in its atmosphere, which helps researchers understand how big planets were created? How it is possible that giant weather systems remain so stable? What is the nature of the magnetic field and plasma surrounding Jupiter? Juno was selected in 2005 and was originally expected to launch in June 2009, but was delayed until August 2011 due to NASA budgetary restrictions. The schedule change posed challenges for the Juno team, wrote Rick Gramier, the project manager for Juno, in a 2008 blog post. Inflation would add cost, as would the personnel and management expenses of a longer project, even with the team size frozen at a low level during the early years. Another challenge, he added, was figuring out how to maintain our heritage designs and retain skilled personnel, making the best use of their expertise during the suddenly extended early stages of the project. The team decided to take advantage of the unusually long Phase BA planning phase to find and reduce the risks to the spacecraft's development. With 3 years to work with instead of the usual one, they hope to avoid design changes late in the game, communication gaps and other matters. Juno launched from Cape Canaveral Air Force Station on August 5, 2011. While 8 other spacecraft have flown in Jupiter's neighborhood in decades past, part of what makes Juno stand apart is its ability to generate solar power from Jupiter's neighborhood. The other spacecraft relied on nuclear power, but the reserves for plutonium generation have dwindled for NASA in recent decades. Solar power is possible on Juno due to improved solar cell performance, energy-efficient instruments and spacecraft, a mission design that can avoid Jupiter's shadow, and a polar orbit that minimizes the total radiation, wrote NASA in 2016, when Juno broke a solar distance record for all spacecraft. The previous record holder was the Rosetta mission, which arrived at Comet 67 Pc-Horomov-Gerasimenko, beyond the orbit of Mars, in 2014. Before setting out for Jupiter for good, Juno earned a speed boost of more than 8,800 miles per hour, 3.9 kilometers per second when it flew by Earth on October 9, 2013. The spacecraft took images of our planet. It reminded principal investigator Scott Bolton of Star Trek imagery and also listened in on amateur radio signals as part of an outreach effort with ham radio operators. In February 2016, the Juno spacecraft did a maneuver to put it on course for the gas giant for a July 4, 2016, arrival. Independence Day has been an auspicious date for NASA spacecraft arrival in the past. Examples include the Mars Pathfinder and Sojourner mission arrival at the Red Planet 1997 and Deep Impact's planned collision with Comet Tempel 1 2005. Viking 1, NASA's first lander on Mars, was also supposed to touch down on July 4, 1976, but when the spacecraft got closer, pictures revealed the landing site was too rough for landing. Viking 1 successfully landed at an alternate site on July 20, 1976, 7 years to the day after the first human moon landing. Infographic: How NASA's Juno mission to Jupiter works. Several spacecraft have flown by Jupiter en route to other locations in the Solar System, such as Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. Even during the brief flybys, they have been able to glimpse interesting information about Jupiter and its moons. For example, New Horizons caught a large outburst on the volcanic moon Io. To date, however, only one mission stayed for the long-term Galileo. After being launched from Space Shuttle Atlantis in October 1989, Galileo arrived at Jupiter in 1995 and spent 8 years studying the planet and its moons. Galileo's discoveries include finding potential saltwater oceans under the crusts of Europa, Callisto and Ganymede. It also sent a descent probe into Jupiter's atmosphere. Much of the mission's value also came from spending nearly a decade in Jupiter's system, allowing scientists the rare chance to do up-close, lengthy observations of the largest planet in the solar system. Juno focuses solely on Jupiter and is trying to answer at least some of the following questions. According to NASA, how much water does Jupiter have in its atmosphere? This is important to figure out if our formation theories of the solar system are correct, or if they need some work. What is Jupiter's atmosphere like specifically? What are the properties at every layer such as gas composition, temperature and cloud motions? Figuring out the weather on Jupiter will help us learn more about gas giant weather generally. It's important for planets in our solar system, as well as exoplanets. What are the magnetic and gravity fields of Jupiter? This will give scientists some hints of what the interior structure of Jupiter looks like. How does the magnetic environment of Jupiter affect its atmosphere? Part of that study will come through looking at auroras. During Juno's calibration phase in August 2016, the spacecraft discovered that the famous bands around the planet extend deep into the atmosphere. In February 2017, NASA announced that Juno would remain in its current 53-day orbit throughout the rest of the mission. Managers initially had planned to alter the orbit so that Juno came closer to the planet, but indicated they were concerned that, given the spacecraft had trouble with helium valves in its engine, firing the main engine may result in a less than desirable orbit. A view from Juno in May 2017 showed the rings as never glimpsed before. Jupiter, like all the gas giants in the solar system, has rings, but they are much less spectacular than those at Saturn. Juno's picture was the first to show Jupiter's rings from an inside point of view. The team also revealed that particles powering Jupiter's auroras appear to be different than those that make Earth's auroras glow. Also, the poles feature gigantic cyclones, and none of the zones and belts that are visible at more equatorial latitudes. High-altitude clouds appear to be snowing material in the upper atmosphere. Even more weirdly, the core appears larger and more diffuse than scientists previously anticipated, which has implications for our understanding of how Jupiter formed. Juno took many images of Jupiter's iconic Great Red Spot, a gigantic storm, in July 2017. Scientists are interested in why the storm persisted for so long, and why it has been shrinking for the past several decades. Meanwhile, citizen scientists continue participating through the JunoCam instrument, which takes pictures for people to process on their own time. Some examples of collaborations include a picture of moons Io and Europa in October 2017 and a stunning view of Jupiter's clouds released in September that year.